Dear students, welcome back to YouTube class. In motion in a plane chapter, we have completed the first video. In first video, we have discussed about scalars and vectors, representation of the vector, and thereafter types of vectors. Afterwards, in present class, video class, we are going to discuss about addition of vectors. That means, suppose if there are two vectors are there, how we are going to add the two vectors? How the one vector can be added with the another vector? Right? More than two vectors are there. How to add the more than two vectors? Now to study this one today, graphically, of course, graphically means with the line segment we have to add the two vectors. Now to study this one in present class, we are having addition of two vectors in which to add the two vectors there are some methods are there. What are those means? Triangle law of vector addition, parallelogram law of vector addition. That means to add the two vectors, if you add the two vectors, these two methods we can use in order to add the two vectors. For the addition of two vectors, there are two methods are there. One method is nothing but triangle law of vector addition, and other method is nothing but parallelogram law of vector addition. Suppose if more than two vectors are there, greater than two vectors are there, two vectors greater than two vectors, then which law we have to use means polygon law we have to use. Polygon law of vector addition is useful to add the more than two vectors. Right. Here mainly in this class we are going to discuss about these two. What are those means? Parallelogram law, triangle law of vector addition and parallelogram law of vector addition. Now let me study about them. Okay, very clear. Right, in which I am going to make here very first one, triangle law of vector addition. That means with the method of triangle law of vector addition, how the two vectors can be added, addition. Right, by using the parallelogram law of vector addition, how the two vectors can be added. Okay, about them we will study right now in this class. Yes, get ready. Yes. Right. To be add the two vectors, to add any two vectors, there are two laws are there. Triangle law of vector addition, parallelogram law of vector addition. In every law, you just see the statement, how the statement has been. How to add the two vectors, to be add the two vectors. Right. If the two vectors can be represented, whatever the vectors we have to add, if the two vectors can be represented, both vector is having both magnitude and direction by the two sides of triangle. By the two sides of triangle. Here I am underlining by the two sides of triangle taken in the same arc. Taken in the same arc. Right, two vectors which we have to add, those two vectors we have to take as the two sides of the triangle in same arc. How it is evident. Then they resulted. Then whenever you take the two vectors which you have to add, those two vectors when you have taken in same order, okay, then two vectors are added. Then after adding the two vectors, the resultant can be represented both in magnitude and direction by the third side of the triangle. Third side of the triangle taken in the which are opposite arc. Sir, how we have to understand this? Okay, let me see here. I am having here two vectors. Now this is a vector. Okay, the vector name is nothing but a bar. A bar. Right. Somewhere here I am having another vector. Okay, the vector is nothing but what is that? B bar. See, there are two vectors out there. A bar is one vector, B bar is another vector. Is it? Now these two vectors we have to add by using triangle law of vector addition. Right? If you want to add these two vectors means, okay, these two vectors magnitude and direction as it is we have to take and we have to arrange as a two sides of triangle in same order. Same order means, okay, second vector tail should be coincidence with first vector head. Second vector tail should be coincidence with first vector head. So first vector where I am going to take here means here I am going to take. Now this is nothing but a first vector. As it is I am taking just to see magnitude. See this much length is there, right? That much length I am taking here. Now this much length is there. See, this is nothing but a bar vector. Okay, now a bar. This is the a bar. A bar is being like this. At the same time, direction also same. Right now, this is which vector means this is the vector a bar. Okay. Next one. Here same order taken in the same order. Here just see taken in the same order means, okay, B vector tail should be coincidence with head of the A vector. So same in this direction only you must take here B vector. See B vector, same direction. Same length. See same length. Here also same length I am taking. Now this is nothing but B vector. Now B vector. Right now this is the method to keeping the same order. Same order. That means here tail of the second vector is coincidence with the head of the first vector means then the two vectors are arranged in same order. Then the two vectors are added. B is added with A vector. Then A and B, two are added. See 2 plus 3. 2 plus 3 is equal to how much? 5. That means 2 plus 3. If you just consider two vectors A and B, then their resultant is nothing but 5. 5 also we have to show in this diagram. Sir, how to show this 5? That means resultant vector. What is the resultant of addition of these two vectors means? Resultant can be taken as the third side of the triangle. In which order? Opposite order. Opposite order means head of the resultant vector is coincidence with the B vector. Okay, right. Two heads are coincidence, opposite order. One tail, one head have coincidence means that is said to be opposite order. Here opposite order means, okay, two heads are coincidence with each other. Now this is I am representing here third side of the triangle. This is the third side of the triangle. Right. Now the third side of the triangle, what it gives means it gives the A bar plus B bar. A bar plus B bar. Now this is A bar, this is B bar. A bar, B bar is added with A bar means then the resultant is A bar plus B bar. This A bar plus B bar is given by the third side of the triangle. So of course this is resultant. So what we can write means resultant vector R bar is equal to A bar plus B bar. Now this is the triangular law of vector addition. In the method of triangle law of vector addition, how to add the two vectors means, okay, B tail must be coincidence with head of A. This is the A vector, it's the head. A vector's head is coincidence with the tail of the B vector. Then A bar and B bar both are addition with each other. The resultant of addition of these two vectors. Of course, addition of two vectors is nothing but A vector. The vector, resultant vector R bar can be represented by A bar plus B bar, which is it? Now this one is good. If the two vectors A bar and B bar can be represented both in magnitude and direction, by the two sides of the triangle. This is triangle only. Yes, by the two sides of triangle. Right, taken in the same arm. Same arm means tail is joined with head. Then they resulted. These two resultant can be represented both in magnitude. Magnitude means length. Okay, a plus b both are added means okay length will become increase. Value will become increase. That means that's why only this line is very lengthy. Right. Then their resultant can be represented both in magnitude and direction by the third side of the triangle taken in the opposite arm. Opposite arm means head to head must be coincide. Now this is the triangular law of vector. Now let me see here. What is the parallelogram law of vector? Now in order to have the addition the two vectors in parallelogram law of vector addition. That means in this method. See, the two vectors can be represented both magnitude and direction by the two adjacent sides of parallelogram. By the two adjacent sides of parallelogram drawn from a point. Then their resultant can be represented by the diagonal of the parallelogram, drawn from the same point. You just see, once again I am going to take two vectors. Now this is nothing but vector. Which one? This is the vector A1. And here I am having another vector, that is nothing but B bar. Vector, this is B bar, and this one is nothing but A bar. Now, this A bar and B bar are added in triangular law of vector addition like this. Right? The same vectors A bar and B bar, how they can added? In parallelogram law of vector addition means these two vectors we have to arrange as a two adjacent sides of parallelogram from a point. Now you just look at here. A as it is in same direction, I am taking here, this is the A bar. See, length and direction both we have to take correctly. Correctly we have to take both length right. See, A bar I am representing here. Now this is the A bar. This is A bar. Okay, right. A bar. See, A bar, however it may be here, same direction I have taken. This is the A bar. Okay, fine. B bar. B bar means A bar and B bar both are drawn from a point, from a same common point. So B bar, this B bar I am arranging here. So B bar, this is the B bar. Same length, same direction. See, it is in crosswise. Okay, I am also here. I am drawing in crosswise manner like this. Yes, fine. Now, this is nothing but which one now? This is the B bar. A bar and B bar. B bar. Okay, fine. Drawn from two adjacent sides. See, adjacent side means pakka sides ಆಗಿರುತ್ತೆ. A bar, B bar. ಎರಡು ಪಕ್ಕ ಇದಾವ? Yes, are there. Next, see, I am going to construct a full parallelogram. See, I am going to constructing here a full parallelogram like this. That means parallel to A, one line I am drawing. Of course, parallel to B, here one line I am drawing. Is it? Now one parallelogram I have got. What is the name of the parallelogram? OQSP. OQSP is a parallelogram. I have constructed. Right? In parallelogram law of vector addition, two vectors can be acting as a two adjacent sides of parallelogram drawn from a point. Then they result in addition of these two. That means this one A bar and B bar both added in this method. Then their resultant can be represented by diagonal. Diagonal means the line in between two opposite corners. See, diagonal drawn from the same point. Same point means A bar and B bar. From where you have drawn, from the same point you have to draw the diagonal. See, I am going to draw the diagonal here like this. From this center to, okay, yes. Yes. This center to yes. Yes. Till the yes, I have drawn. Right here also to show the direction. Now, what is this one? This one is nothing but this line is completely A bar plus B bar. Completely this line is used A bar plus B bar. That means resultant of A bar plus B bar is nothing but R bar. R bar is equal to what I got now? A bar plus. See, to add the two vectors, in order to addition the two vectors, here I am having two laws. One is triangular law of vector addition, other one is parallelogram law of vector addition. In triangular law of vector addition, two vectors can be added like this. In parallelogram law of vector addition, two vectors can be added like this. Here, two vectors have taken two sides of the triangle in same order. Then resultant is, okay, third side of the triangle in opposite order. Here, in parallelogram law of vector addition, two vectors can be, okay, drawn from the point as two adjacent sides of the parallelogram. This is the shape of the parallelogram. Right? Then their resultant A bar plus B bar resultant can be represented by the diagonal of the parallelogram drawn from the, okay, same point. See? Yes? Once you see, okay, very easy ones. Right? Yes. Now, after having this one, for triangular law of vector addition, it is not necessary. If you come to the parallelogram law of vector addition, sir, this is the resultant vector in parallelogram law of vector addition. R bar is equal to A bar plus B bar. Sir, this is the vector form. In vector form, we are having the parallelogram law of vector addition. But what is the magnitude? Okay, vector means it is having the direction and magnitude. This is being in the form of, okay, magnitude and direction form. But I don't want what is the magnitude, what is the direction. I want only the resultant vector in the form of magnitude. So for that, we have to derive the expression for, okay, magnitude of resultant vector in parallelogram law of vector addition. In this parallelogram law of vector addition, for this resultant vector, we have to derive the expression for magnitude. Now that is our aim right now. See, look at here. Very, very important for 3 marks. Right. Look at here. Very important for 3 or 5 marks question. This is expression for magnitude of resultant vector in parallelogram law of vector addition. See, I am going to derive this one. Once again, what is the statement of parallelogram law of vector addition? If the two vectors can be represented by the two adjacent sides of parallelogram. This is the parallelogram. For this parallelogram, for a two adjacent sides, as a two adjacent sides, okay, there are acting two vectors. Now see, this is nothing but vector A bar and this is nothing but vector B bar. See, I am making one complete parallelogram here. Now this is nothing but O. Of course, this is Q. This is P. This one is P, point B, and this one is nothing but point S. Okay, I have made it like this. Now then, their resultant can be. Sir, what is the angle between the two vectors at this point? At this point, angle between the two vectors is nothing but theta. What is the angle between A bar and B bar? Means angle between A bar and B bar is nothing but how much we can take? We can take that is nothing but theta. Is it? Now from this one, you just look at here once again. Right. What is the resultant of these two vectors? Means resultant of these two vectors can be represented by, okay, some another line. That line is nothing but diagonal line. This diagonal line is drawn from the same point. That means the point from which we have drawn. See, now this is the diagonal line. Right now, this is the diagonal. Right, this diagonal, what it can represent means diagonal line can be represents A bar plus B bar is equal to R bar. It can be represents. That means you are observing R bar. Okay, this line is making an angle. How much? That is alpha with which one mark? Otherwise, we will take it later. Okay, right. Now, this is the parallelogram law of vector addition. Now, from this parallelogram law of vector addition, that means on adding the two vectors A bar and B bar, whatever the resultant we are getting A plus B. For this A plus B, we have to find out the resultant. Resultant we have to find out in terms of the magnitude. We have to find out. Now to find out this one, first given things you write. OP bar is a vector which is equivalent to A. Is it? Next one. OQ bar. Right? OQ bar. Of course, this OQ bar, OQ is parallel to PS. So OQ bar is equal to PS bar is equal to. What is there here? B bar is there. So I can write here B. Next one, OS bar. OS bar is equivalent to what I can write here? R bar. Of course I can write. Otherwise, A bar plus B bar I can write. But we don't want this one. We want R. So here the given things I have written in terms of the vectors. But in only magnitude. Only magnitude means we have to remove the bar. Right? OP is equal to what I can write? A. In similar way, OP is equal to, of course I can write A. In similar way, OQ is equal to PS is equal to B I can write. In similar way, OS is equal to what I can write means R I can write. Otherwise, modulus of A bar plus B bar I can write. That means magnitude of A bar plus B bar also I can write. Now I have to find out the magnitude R I have to find out. Otherwise, modulus of A bar plus B bar I have to find out in the parallelogram of vector addition. Now, to find out this one, which one we have to find out? Okay, magnitude. To find out the magnitude, see what we have to do means we have to extend the OP. OP we have to extend a little bit by extending this OP. You just see extending by OP, right, like this, extended. And I have drawn a perpendicular from S to this extended line. See, by extending OP line, by extending, I have drawn a perpendicular from S to extended line. Up to where I have drawn? I have drawn up to N. Is it? Now, this is the horizontal line, this is the cross line. Okay, here angle between these two theta means here also angle between these two. How much I can take? Theta I can take. Now, by drawing these two dotted lines, okay, PN and SN. Additionally, that means what I got here two right angle triangles. One is nothing but P S N, other one is nothing but O S N. O S N. Two right angle triangles. One is nothing but P S N. One right angle triangle. O S N. Another right angle triangle. By considering these two right angle triangles here, we are going to derive the expression for magnitude of the resultant vector in parallelogram law of vector addition. Now for this one, by using the, look at here, by using the by using the right angle triangle, by using the right angle triangle. See, this is the symbol for right angle triangle. Right angle triangle PSN. By using the right angle triangle PSN. Let me see what we have to calculate. PSN, right angle triangle I have taken. In which very first what I am going to take means from this right angle triangle I am going to measuring sin theta. Sin theta. What is the sin theta formula? Sin theta formula is nothing but opposite to hypotenuse. What is the for this theta? What is the opposite line? Is nothing but SN hypotenuse line. Now sloped line. What is the hypotenuse line? Is nothing but PS. Right, from this one, this SN is unknown thing. Let me find out SN. SN is equal to what we can write PS will come this side means PS into sin theta, of course. Now from this one, SN is equal to what I can write means PS. What is the PS value here? B. PS value B means you write here B. Remaining is nothing but sin theta. B sin theta is nothing but here. Okay, what I got? B sin theta is nothing but I got, okay, the normal line which I have drawn. SN is equal to I got B sin. Okay, fine. Next, by using the same one, okay, let me measure here cos theta. Right here, let me measure the cos theta. Cos theta is equal to, what is the formula? Cos theta equal to adjacent side by hypotenuse. Adjacent side is PN. Hypotenuse is PS. Now from this one, PS will come this side means that equal to PS cos theta. Okay, PS cos theta. Next thereafter, here, what is remaining? PN. Right, once again, what is the PS value? PS is equal to B. So, PN is equal to, we can write B cos theta. Whatever the dotted lines we have drawn, okay, one is nothing but PN, other one is nothing but S. These two unknown values we got here. Okay, by using this one. Next, thereafter, first one, which one I have taken? I have taken the right angle triangle PS. Next, by taking the same other one, OS1 right angle triangle, right? By applying the Pythagoras theorem to the right angle triangle. Right angle triangle OSN. OSN we have. OS. What is the Pythagoras theorem? Square on the hypotenuse equal to sum of the square on the other two sides of the triangle. What is the OSN? In which, what is the hypotenuse? OSN. Like, look at here. OSN square, OS square is equal to, look at here. ON square plus SN square. SN square. Is it? Pythagoras theorem I have applied. Square on the hypotenuse is equal to sum of the other two sides. Other two sides of the right angle triangle OSN. Okay, for this one, other two sides is nothing but ON is one side, OSN is another side. Yes. Okay, fine, you just come. Okay, thereafter, ON means, really, here see, ON means what I can write? ON is equal to OP plus PN. So, OP plus PN whole square plus, I can write SN square. Now for this one, let me apply a plus b whole square formula. A square plus b square plus 2ab sin theta. A square op square plus b square pn square plus 2a. Instead of a, what is there? Ob. Instead of b, what is there? Pn. Into what I can write? Plus s n square again. Now from this one, OS square I got, okay, this much. Now let me substitute the values. OS, what is the OS now? R. So here I can write OS is nothing but R square is equal to OP. What is the OP? A. AS square plus PN square. What is the PN square? Is nothing but B square cos square theta. Right? B square cos square theta we can write plus next to 2 into OP. What is the OP? Is nothing but A. Right? A. Next to PN. What is the PN? Is nothing but B cos theta. Right? Let me write B cos theta. Fine. Plus SN square. SN square means here is the SN. SN square means B square sin square theta we can write. So B square sin square theta. Now from this one, R square is equal to A square plus here you just see in this term and in this term, in both terms, what is the term is common? B square is common. If you take from these two terms, B square is common means, so in bracket remaining is sin square theta plus cos square theta. Okay, next bracket close. Yes, close the bracket. Plus remaining is 2ab cos theta. Now sin square theta plus cos square theta, the value is 1. So R square is equal to what I can write? A square plus B square into 1 plus what I can write? 2ab cos theta. Now from this one, R square is equal to I have A square plus B square plus 2ab cos theta is it? Now one side square is there. Now other side these two terms squares are there. Okay, here there are no squares. Okay, in both sides if you apply the square root, right? By applying the square root on both sides, by applying square root on both sides, right? Let me see here. Under root R square is equal to square root of A square plus B square plus 2ab cos theta. Right? Here square root and root both are cancelled. So the remaining is R. R is equal to remaining. R is equal to see here this square B square are there. These squares are not going to square cancel the square. Okay, let it be like this. So square root of what I can write? A square plus B square plus 2ab cos theta. Now this is nothing but the expression for resultant vector in parallelogram law of vector addition. Right? Magnitude of resultant vector. Right. Expression for magnitude of resultant vector in which one ma? Parallelogram law of vector. That means modulus of a bar plus b bar means how much I have to write? A square plus b square plus 2ab cos theta under root. Or only R bar is there. R bar means okay, A bar plus B bar. Only R. Only R means square root of A square plus B square plus 2ab cos theta. Like that we have. Okay, right. Thereafter, here magnitude we have there. Then, sir, what is the direction of resultant vector with A bar? With A bar. That means A bar vector in the resultant vector ಎಷ್ಟು degrees ಅಲ್ಲಿದೆ. To find out this one, once again we are having an explanation. See result. Look at it. Next continuation. After having this one, continuation. Direction of R bar with A bar. Direction of R bar with A bar. Okay, let me see. Now, right, look at here. See, this is the A bar and this is the R bar. What is the angle between these two? Angle between these two. Suppose if you take alpha. In between A bar and B bar, angle is theta. In between A bar and R bar, angle is alpha. Now, from this one, right, to find out the alpha, that means at what angle? That means from A bar at 20 degrees or 30 degrees or 40 degrees or 50 degrees. At what angle this R bar is being? Now, to find out this one, okay, we are here. Right, what does that means? Very first one. Okay, let me see here. Right, once again, from the right angle triangle OSN, right, OSN, right angle triangle is there. From this one, okay, I will take tan alpha. Angle is tan alpha. Tan alpha equal to, what is the formula? Opposite by adjacent side. Opposite is SN, adjacent side is ON. So SN divided by ON. Once again, SN divided by ON means we can write OP plus, okay, PM, we can write OP plus PM. Right, from this one, tan alpha is equal to SN is, what is there? B sin theta. So B sin theta divided by next to OP means A. OP means A plus PM. PM is nothing but B cos theta plus B cos theta. Right. Now this is the one of the formula for this one. Otherwise, alpha equal to, if you send the tan this side, okay, what I may get? Tan inverse of bracket begin B sin theta divided by A plus B cos theta. Okay? Now this is nothing but here, okay, expression for direction of the, right. Now this one is direction of R bar with B bar. Yes, now this is the direction difference, right. Now afterwards, right, Sima, to derive the expression for magnitude of the resultant vector in parallelogram law of vector addition, see, I have drawn the OP bar is equal to A bar. OP is nothing but A. This is only in terms of magnitudes. These are in terms of the vectors. First, to solve this one, I have to make two triangles. To create the two triangles, right? Two triangles are nothing but PM. By extending the OP line, here PM, one line I got. Here SN, another line I got. Now just see OSN, one right angle triangle. At the same time, PSN, another right angle triangle. From these two right angles, first by using the PSN right angle triangle, SN value I got by taking sin theta, by taking cos theta, PN value I got. Next, by taking the OSN right angle triangle, for this OSN right angle triangle, I have applied here Pythagoras theorem. Right, Pythagoras theorem has applied to the OSN right angle triangle here. Now, by applying the Pythagoras theorem, what is the statement of Pythagoras theorem? Square root of hypotenuse OS square equal to sum of this. Sum means plus other two sides, ON square plus SN square. Right, from this one I got like this. Thereafter direction also like that. Now afterwards, Based upon this, there are some special cases are there. Okay, let me solve. Right? Yes. Right, look at here in special cases. I have put this one. Okay, I need this equation because of that. Right, if the two vectors are in same directions, actually A bar and B bar in having some angle. Suppose A bar and B bar in same direction means A bar and B bar are parallel vectors. Okay, for parallel vectors same directions, then theta equal to how much ma? 0. Theta equal to 0. In that case, what is the resultant vector means? R bar is equal to square root of a square plus b square plus 2ab in same direction. Cos theta value is 0. Cos 0 value is 1. Cos 0 value is 1. So cos 0 value is 1 means, okay, R bar is equal to what I can write? Remaining is a square plus b square plus 2ab. 2ab. A square plus b square plus 2ab is nothing but a plus b whole square we can write. A plus b whole square is in which this one cancel means what we can write? A plus b. So when the two vectors are in same direction, then the resultant vector is nothing but a bar plus b. So the two vectors magnitude are add up with each other. Next one. Second case, if the two vectors are in opposite. The two vectors are in opposite. If the two vectors are in opposite direction means angle is nothing but how much ma? 180 degree. So R is equal to square root of a square plus b square plus 2ab cos 180. Cos 180 value ಎಷ್ಟು ಅಂದ್ರೆ -1. Cos 180 value -1. So I can get here a square plus b square minus 2ab. Now from this one I may get here, okay, a square plus b square minus 2ab means a minus b whole square. So this one cancel means resultant vector R is equal to, we can write a minus b. That means when the two vectors are in opposite direction, the vectors can be, okay, subtract from each other. Magnitude of the two vectors subtract from each other. So I can write, okay. Next one, suppose if the two vectors are orthogonal, if the two vectors perpendicular symbol or bracket ಅಲ್ಲಿ orthogonal. Orthogonal means theta is 90 degree. So R is equal to resultant vector a square plus b square plus 2ab cos 90. Listen, my cos 90 value is 0. So what I will get here? So a square plus b square plus 2ab into 0. So the resultant value is R is equal to square root of a square plus b square. So this is nothing but here, okay, resultant vector when the two vectors are orthogonal, perpendicular to each other. Right? Now this is the concept which is related to the special cases of the parallelogram law of vector addition. Yes, make it.